For this part, we will introduce the packet and the encapsulation. Okay, first we will focus on the OSPF packet types and the encapsulation. And for the OSPF packet, actually is encapsulated in IP packets, and the protocol number is 89. So here we can see the capsulation format. And we can see here is the level 2, right? Is the level 2 header. And this is the level 3 header, right? The level 2 header has the MAC address information, and the level 3 header has the IP address information. Okay, and this is actually the OSPF packet's payload. And for the OSPF packets encapsulated in IP packet, so for the IP packet, we capture the packet and then we find the protocol parameter. The number is 89. So you can see this parameter in this part. Okay. And for the next part is the OSPF protocol message. Here for the OSPF protocol message, we have two parts. One is the OSPF protocol header, and second is OSPF message tabs. And for the OSPF, actually, we have 5 tabs of the packet. First is the hello, and second is the DVD, and the next is the LSR, and the next is the LSU. The last is the LSACK. We have 5 tabs OSPF packets. So during the two routers to establish the neighborship and to form the database and to calculate the routing table. So during this progress, we have to exchange the hello, DVD, LSR, SNU, LSACK, these 5 tabs packets to each other, and then to establish the neighbor relationship to form the database. Okay, so this is 5 tabs packets functions. So here now we will learn more details about this 5 message. So first is the hello message, and we can say for the hello message, the function is to establish the neighbor relationship and maintain the neighbor relationship. So for the neighbor relationship, it's very important to exchange the hello message between two routers. And next is the DBD. Actually, the DBD is the list of our RSA. So we know the RSA includes the detailed information about our network, and we use the RSA to build the database, right? And for the DBD, actually, two routers will exchange the DBD packets. And the DBD packet has the RSA header information, not the detailed RSA information. It's just the header information. And the header information to describing the RSDB to its neighbors. So this is the DBD message. And after we exchange the DBD information, and we have to change the LSR because the router has the DBD information, and then the router will find which information or which RSA I don't have. So when the router finds the problem, and then the router will send the LSR. So the LSR means the link state requests message. So it means the router will use the LSR to request the LSA information. Okay, and after the router send the LSR and the peer router receive this packet, the peer router will answer the LSA. So the LSA information will included in the RSU packet. So the RSU is the link state update message, carries the RSA information. So the RSA information will include the detailed parameters uh, about every router, about every segment, about every interface. So the RSA will build the RSDB, right? So the RSA will build the RSDB. And the RSDB means the whole information, means the whole network, means the whole topology. Okay. So after we exchange the RSU information, to reply the RSU, we will use the RSACK. So the RSACK is a link state acknowledgement message. For the router, receive the RSU, and the router have to use the RSACK to reply to the peer router. I have received your RSU message. Okay. So for the RSACK, actually is the acknowledgement of RSA information received in RSU. This is the 5 types of OSPF packets introduction. And now we will know every packet and we'll learn more details about the 5 types of OSPF packets in next page. And for this page, we'll introduce the more details about hello packet. And for the hello packet, we can say it's very important for the OSPF neighbor establishment. We will use the hello packet to say the hello to peer router and to build the neighbor relationship. And after we build the neighbor relationship, we have to send the hello packet and to maintain the neighbor relationship between each other, right? We have to keep the neighbor relationship between two routers. So this is the hello packet function. Actually, we also use the hello packet to elect the DR and the BDR and the DR other. So the hello packets function is very important. And here we can see this is the format for the hello packet. And first, the version 2. It means this is the IPv4, right? It's the IPv4 packet. So next parameter is a type 1. It means this packet is a hello packet. And the next is the packet length. Okay, and the route ID. So here is the route ID information in hello packet. For example, like the 1.1.1.1 or 2.2.2.2. And the area ID means you belongs to which area, such as area 0, area 1. Okay, this means you belongs to which area. And the checksum is to check the integrity of the packet and keep the packet safety, right? And next is the authentication tab. And for example, we use the authentication as the clear text or the simple text. Okay. And next is the authentication date. We set the password here, right? And next is the mask. This means the router's segments. Okay, maybe the 24 or 30. And next is the hello interview or the hello time. Okay, maybe the 10 seconds. And the dead interview is the 4 times to the hello interview. So if the hello interview is the 10 seconds and the dead interview is the 40 seconds. Okay. So other is the options and the priority. So the priority actually used to elect the DR and the BDR and the DR other. We will compare this parameter to elect the different router rules. Okay, and next we'll contact the more information like the DR and BDR neighbors information into the hello packet. So here we have so many parameters, but now we don't need to know every parameter in the packet. We have to focus on the 7 fields in this packet. First is the root ID, and second is the hello or data time or the data interview, and the area ID authentication, step ID, and the interface subnet mask, network type of interface. The 7 fields, because the 7 fields have some rules we have to follow, and then the neighbor relationship will build successfully. If we won't follow these rules of the 7 fields, so the neighbor relationship can't be established. Okay, so first is the root ID must be different. It means the two routers, okay, to establish the relationship between each other. So for example, this is 1.1.1 and this is 2.2.2.2, and we send the hello packet between each other, right? We send the hello packet between each other, and the 1.1.1 sent to the packet to the 2.2.2, and the root ID is a 1.1.1. And for another router, the root ID is a 2.2 is different. But if we configure the root ID on this router is become a 1.1.1, so the root ID will be conflict with each other, right? So we have to keep different router has different root ID. Every router has only the root ID for the router to use. Okay, so we have to follow these rules and keep the root ID of every router is only. So this is the root ID. And next is the hello and dead time. Also we can set is hello and dead interview. It's the same. Must be same. It means the two router, the hello or the 10 seconds, and the dead time is 4 times, right? So it's 40 seconds. So for the two router, we have the same hello time and dead time. So if we use a command to change the hello interview or the dead interview on our router, we have to change at the same time. Like we change this router to the 30 seconds. So for this router, we also have to change the parameter to the 30 seconds. Okay. And next is the area ID. So for the area ID must be the same. It means the two router belongs to one area, such as the area ID is 0. It means two router belongs to the backbone area. Okay, after this is authentication. So for the authentication, we have two parts. First is the authentication tab, and second is the authentication date, right? And for the authentication tab, we will set the authentication tab to be the clear text and the ciphertext. Okay, and so if we set the one router become the clear text, so another router we also have to set the authentication tab as the clear text. So the tab has to be the same. And after we set the authentication tab, we have to set the authentication password. It's the authentication date, right? So on one router, we set the password to be Ruijie, and another also we have to set the password to be Ruijie to keep them the password to be the same. So after this is a step ID. So the step ID actually means you set this router to become the step router. It's become the step area. So if you use the command like the area 2 step, right? And it means this router belongs to the area 2, and then this router becomes to the step area. So to another router, if you want to build the neighbor relationship between the 11111, and you have to set the same comment on the route 2. So we also have to set the area 2 step on the R2 device. So we have to keep the step ID to be the same. And then next is interface subnet mask. So it's very easy to understand. We have to set the two router to be the same Ethernet environment, such as the 24, such as the 30. We have to set them to be the same interface subnet mask. Okay. And the next is the network type of interface. So for the network type interface, we have introduced, we have the P2P, P2MP, MBMA, and broadcast, right? So for the two routers, if this router is a broadcast, so another router we have to set to become the broadcast. If this router is the P2P, and we have to set the another router is the P2P. If we want the two routers build the neighbor relationship between each other. So actually, the neighbor type of interface will affects the router calculation. So we have to keep the network type to become the same. Okay. So this is the 7 fields we have to focus on it, and we have to focus these rules to establish the neighbor relationship between two routers can build the successfully. Okay. And next page. Okay, here we can see the hello package which is captured by the Ruijie, and we open the hello package and we can see here is the open shortest path first and the OSPF header and the OSPF hello package. Here is the header includes the version information, message tab. So this means the hello package. And packet length is 48. The source OSPF router is 2.2.2. It is route ID information and area ID. So it belongs to the area 0. It's the backbone area. And the checksum information and also the application tab is none. It means we do not do the authentication on this router. And for next parameter is authentication date is the none, right? Because we don't do the authentication, so the data is none. Okay, next is the OSPF hello package, and we can see the net mask information is 24, and hello interview and data interview, so it's 10 seconds. The data interview is 40 seconds. Okay, and then the options information and the router priority is 1. Okay, and the DR information, BDR information, and the active neighbor information. So this is the hello package. And next is a DBD package. And for this page, introduce the DBD package, we can say actually the DBD package is the database description information, right? So the DBD package includes the LSA header information, but not include the detailed RSA information because the detailed RSA information is included in the RSU packet. So the RSDB actually stores the RSA into the database. So here the DBD actually is the catalog or the list of our RSA information. Here we can see this is the DBD packet format, and we can access this format. Okay, so first part is the version. Of course, it's version 2. It means the OSPF v2. So it's part of the IPv4 environment. And next is the tab 2. It means this packet is the DBD packet. Okay, so the tab value is 2. And next is the packet length. And then is the root ID information, for example, 101.101, okay, area ID, for example, area 0 is the backbone area, and the checksum to keep the packet integrity, right? And next is the authentication tab, of course, it's the same with the hello packet, maybe the clear text, maybe the zebra text. So next is the authentication to set the password, right? Okay, and then is the interface MTU. For example, the default MTU value is 1500. Okay, and next is the options, and the next we can see the 3 bits. Here is the I, M, and MS 3 bits. So for the 3 bits, what does it mean? So for the first bit, we call it initial bit. Initial bit. So for the initial bit, actually, it means the first DBD packet. So if the value is 1, the 1, it is this packet is the first DBD packet. Okay, and if the value is 0, so it means this packet is not the first DBD packet. Okay, and then next bit we call it master slave bit. So it's weird used to show this packet is sent from the master or the slave. So here we can see if the MS is 1, and it means this packet is the master. Okay, if the value is 0, it means the slave. Okay, so this is the MS bit, and next is the M bit. The M bit actually is a more bit, and for more bit it means it is not the last DD packet, or it is the last DD packet. And the value is 1, it means this packet is not the last DD packet. And follow this packet will have more DBD packet. So if the value is 0, it means this packet is the last DBD packet. So after this packet, no DBD packet. Okay. And after 3 bits, next is the DD sequence number and the RSA header. So for this part, actually has the RSA list or the RSA catalog information included in this. Okay. So this parameter provides all the RSA header information for matching by the peer. Okay, so we receive the RSA header information from the peer router. Okay, so next let's see the real packets which captured in our network. Okay, here is the 2 DBD packet, and first we can see this is the OSPF header, and it will include the version information, tab information, packet length information, root ID, area ID, checksum, authentication tab, and authentication password, right? And except this is the payload of the DBD packet, and we can see the MTU information. Here the MTU is 1500, right? Okay, this is the value of MTU. And then is the option information. The option information is about the external routing. Okay, next is the DB description. Here we can see the DB description is include the IMS. So here is packet we can see the initial is a 0. Okay, it means this packet is not the first DBD packet. And then the M is more bit will be set to 1. It means follow this packet, we will have more DBD packets, right? And next is MS. So the MS value is a 0. It means this packet is from the slave, right? It's not from the master. And next is a DD sequence. And follow the DD sequence is the RSA header information. Okay, from this is the RSA header information, and we can say the RSH, okay, and the do not H flag information. And except this, we also can see the options include the S tab, link state ID, advertising router information, sequence information, checksum, and length. So this is the DVD packet. So after this, we can see another DVD packet here. It's a same with the OSPF header, and here we also can see the DVD description for 3-bit. One is I in nature, so of course this is not the first DVD packet, and here the more bit set to 1. So it means follow this DVD packet, we will have more DVD packets. And next is the MS. So it means this packet is from the master router, right? Okay. So this is the DVD packet information. Okay, after this, we will go on next packet. And for this page, we can see the LSR packet. Actually, the LSR, it means the link state request packet. So for the request packet, actually, here is 2 routers, okay, and this is R1 and this is R2. Actually, first we have to build the neighbor relationship, okay, use the header packet, right? And then we have to exchange the DB packets to see the RSA catalog, see the RSA header, and then after we exchange the DBD information, maybe the R1 has the 1, 2, 3 RSA information, right? And the R2 has the 2, 3 information. But the R2 don't have the 1 RSA. So when the R2 and the R1 exchange the DBD packet, and the R2 find I don't have the 1 RSA, so I need the 1 RSA. Now the R2 will send the LSR to request the LSA information. Maybe I don't have, or maybe I missed it. So when the R1 receives the LSR, will reply the LSA information to the R2. Okay, so actually this is the LSR's function. So the LSR packet is request the LSA information, and this LSA information actually in LSR is not the detailed LSA information. It's just the partition date in the LSDB. So the LSR packet in this process will store the partial RSA information, okay, not the detailed information. So now we can see the format of the LSR packet. First, of course, the version, and second is the tab. So the tab value is 3. It means this packet is the LSR. And next is a packet length. And then the root ID maybe 1001, okay. And the area ID maybe backbone area or the non-backbone area, okay. And then the checksum. The checksum. And the next is the authentication tab. And then the authentication password message, okay. And then the LS tab, link state ID, advertising router. So for this part actually is the important thing for LSA packet, right? So the LSR will include this information and to request which LSA I want to use or I want to request. So please send me, right? So we will use this information to start requesting the specific LSA based on the DBD packet from the peer. So this is the LSR packet. After this, we can see the LSR packet details here. Here is the OSPF header, right? And for the OSPF header, it's the same with the hello packet with the DBD packet, include the version information, message tab information. But here, the message tab is the 3. It means this is the LSR packet. And next is the packet length and source of OSPF router. And so this packet is from the 1001, this route. Okay. Next is the area ID information and the checksum, authentication tab, authentication date. Next is the LSR packet information, and we can see the LS tab is the root LSA. It means now I want to the root LSA. So the root LSA is the LSA type 1, right? And then the link state ID is a 2.2. It means I want to, this LSA is from the 2.2, this router. And then for this LSA, the advertising router is also 2.2.2. So this is the LSR packet. And for another, we can see this packet, the source OSPF router is 2.2.2. And for the link state request information, we can see, of course, we also want to choose the root LSA information. And for this LSA, it's from the 101.1, and the advertising router also is a 101.1. So this two packet it means here are two routers, and the R1 is the 101, and the R2 is the 2.2.2, and the R1 send the LSR information to ask the LSA information, right? And for R2 also want the LSA information from R1. So the R2 send the LSR to request the 1.1.1.1 this LSA information. So these two packets actually show this topology. Okay, so this is the LSR packet. And next go on. And for this page, introduce the LSU packet. Actually, the LSU packet we know is the LS update packet For this packet, it includes the RSA information. So the RSA information is not same with the DBD and the RSR because the DBD includes the RSA header information and the RSR includes the partition RSA information. But for the RSU, actually, the RSU includes the detailed RSA information. So this is the differences between three packets. And the RSU actually is used to reply the RSR packet. So for the router R1, R2, and the R1 sends the RSR packet to R2, and the R2 use the RSU packet to answer the R1, and the RSU packet include the detailed RSA information. Okay, so this is the process for the RSU packet. And now let's see the format of the RSU packet. We can see the version information, tab information, packet length, and the root ID information, area ID. So it's the same actually with other packets. And for the tab value is a 4. The 4 it means this packet is the RSU packet. And next is the checksum, authentication tab, authentication. Okay, except this, we can see the important parts in RSU packet is the RSA. So for this part, actually it includes the detailed RSA information. So for the RSA detailed information, we can see in this packet. Okay, and for this two real packet, here is the OSPF header. So every part actually is the same with other packets. And here we can see this packet, the source router is a 2.2.2, and for this packet, the source is 1.1.1.1. Okay, and after this, we can see the message tab is a 4. And for this is a message tab is a 4. So it means this packet is the RSU packet. RSU packet. Okay. And then we can see the RS update packet information from here. So here the RSA include just one. And for this one RSA information is the RSA type 1 information. And the RSA type 1 information is the router RSA. Okay. And the router RSA information we can see is from the 2.2.2 and the advertising router is the 2.2.2 sequence number and the checksum and the length. So this is the detailed information about the RSA. So we can see another packet. Here is the RS update packet. Okay, and from the RS update packet, we also has just one RSA information and include the RS tab, link state ID, and the advertising router and sequence number. Okay, so we can see the more detailed information in the RSU packet. Of course, we also can see the numbers of links. We can see except the 2.2 or except the 1.1.1.1, we also have 3-step links on this router, right? So the ID is 172.16.1.1 and the data information and metrics information. Okay, of course, about this packet, we also can see the other links on these routers. So we also can see the step information on this router. Okay, so actually the RSU packet will include the detailed information on the router. Okay, so the detailed information such as the LS tab, link state ID, advertising router information, sequence number, or the uh, tab, or the segment, or the metric information. Okay, so let's go on to next packet. And for this page, actually, is the LSACK packet. So the LSACK packet is the last packet for the OSPF. And the two router here R1 and R2 is 1.1.1 and 2.2.2.2. Okay. And for the R1, send the LSU packet. After this, if the R2 received the LSU packet successfully, and the R2 have to answer the LSACK packet to R1. It means I have received your LSA information successfully. Now this is my replay message. So actually this is the LSACK's packet function. And the LSACK packet actually includes the LSA header information. Okay, it includes the LSA header information. So to reply the LSA packet which the router has received. And for the format of LSACK packets is a version and the tab and the packet length and the route ID information, area ID information, and the checksum and the authentication tab. Authentication. For the last is the RSA header. And the RSA header, actually, we can see the RSA packet includes the own RSA header list for acknowledgement by the peer. Okay, so it means when the R1 and R2 exchange the RSR information and the R2 have to reply the RSA-CK packet here, and then the RSA-CK packet will include the header information, such as the R1 sends the 1.1.1.1, this RSA to R2, and then the R2 will reply the RSACK packet, and for the packet will include the 1.1.1.1 this RSA information. Okay, but the information is not the detail, just the header. Okay, and next, let's see the RSA packet captured in our network. Here is the RSACK packet, and we can see the version information, message tab information, and packet length information, source OSPF information. So we can say this is the 2.2.2, this router, and the 2.2.2, this information is the source route ID information. And then the area ID checksum, authentication tab, authentication date. It's the same with other packets. And then we can see the RSA tab information here. It's the router RSA information. The router RSA information is the tab 1, and the RSA tab 1 information includes the RSA tab, link state ID, advertising router, and sequence number, checksum, and length. For this part, actually, is answered to the RSU, right? Is answered to the RSU, and it means this ACK message is from the 2.2 to answer to the 1.1.1, and for reply the 1.1.1, I have received the RSA information. This RSA information is the 1.1.1.1. This type 1 router RSA information. I have received this RSA information successfully. Okay, and for this packet, actually the version information, message information, and packet source. So for this source SPF router is 1.1.1.1. It means this ACK packet is from the 1.1.1.1. And then we can see now we answer the RSACK packet for the RSA type 1 and the RSA type 2. And for the RSA type 1, we have received the 2.2.2, this RSA. And for the RSA type 2, we have received the network RSA information, and the link state is the 10.1.0.2, and this RSA actually is from the 2.2.2. Okay, so this is the RSAK information from the 1.1.1.1. Okay, and when the 1.1.1.1 have received the RSA type 1 and the RSA type 2 RSA information successfully, and then we will answer the RSAK packet, and the RSAK packet include the header with 2.2.2 with the 10.1.0.2, the 2 RSA information. Okay, so this is the RSA ACK packet.